All right, let's jump right in. Today, we're talking about a seriously cool piece of technology that's giving fighter pilots a massive advantage in the air. We're looking at a system that solves a really critical problem, and by doing that, it makes our pilots safer and way more effective. This is some fascinating stuff.
You know, it really all comes down to this one question. When you're in the incredibly high-stakes world of air combat, what's the real practical difference between just seeing a threat out there and actually being able to do something about it? Well, as you're about to find out, the answer is all about one single crucial piece of information.
So first, let's set the scene and talk about the challenge itself. A pilot is operating in this unbelievably complex environment, right? And they're using all these sophisticated tools to try and see what's going on around them. One of the most important tools they have is a system that's designed to spot threats without, and this is key, giving away its own location.
And that tool is called an infrared search and track system, or IRST for short. The easiest way to think about it is like a super powerful, heat-seeking camera. And the keyword here is passive. See, unlike radar, it doesn't shout into the darkness by sending out signals. It just looks. It's watching for the heat signatures from other aircraft. This means it can find a threat with incredible accuracy, all while staying completely silent and hidden.
But here's the catch. Seeing the threat is really only half the battle. IRST is amazing at detecting a target without being seen, and it can tell you exactly what direction that target is in. But it has one huge built-in flaw that leaves a dangerous, and I mean dangerous, gap in a pilot's understanding of the battle space.
And that leads us straight to the heart of the problem, which you could call vision without depth. The system gives you a perfect line of sight to a target, but it's missing what is arguably the single most important piece of data you need to make a combat decision.
And that decisive factor? It's range. A single IRST pod, all by itself, can't tell you how far away a target is. Think about it like this. You're driving on a pitch-black night, and you see a single headlight up ahead. You know something is there, but is it a motorcycle a mile down the road, or is it a car with a busted headlight just a few hundred yards away? That's the exact dilemma a pilot faces. And when you're moving at the speed of sound, that kind of uncertainty is something you absolutely cannot afford.
Now you're probably thinking, well, can't the plane's other systems just figure it out? And that's the other side of this challenge. The existing data links on a lot of these jets are, well, they're already maxed out. They're like a narrow pipe trying to push through a flood of information. All the data from all the different sensors has to get crammed through the jet's central computer, and it creates this massive bottleneck. Trying to solve for range the old way is just way too slow.
So how do you solve a problem like that? This is where we get to the really cool part, the breakthrough. Lockheed Martin's Legion pod now comes with its own dedicated data link, and it completely changes the game.
And what's so brilliant about this solution is that it's inspired by something we all use every single second of every day without even thinking about it, our own two eyes. The way your brain takes the input from two separate eyes to create a 3D picture of the world, that's the exact same principle at work here.
So here's how it works, step by step. You've got Jet 1, and its Legion pod gets a bead on the target from its angle. At the exact same time, Jet 2 sees that same target, but from a slightly different perspective. Now here's the magic. The two pods use their own private data link to talk directly to each other, instantly sharing what they see. They completely bypass the plane's slow, overloaded main computer. The pod's own processor then fuses those two images together to create a single, high-fidelity 3D track that includes precise range, and it does it all in near real time.
Okay, so we understand how the tech works, but let's talk about why it's such a big deal. This whole breakthrough has a massive, direct impact on the pilot in the cockpit. We're talking about making them safer and allowing them to make critical decisions much faster.
This quote here from Ken Nelson over at Lockheed Martin just nails it. By taking this incredibly difficult task of finding range and making it automatic, the system frees up the pilot's brain power. Instead of wrestling with their systems to get the information they need, they can focus on what really matters: tactics and bringing everyone home safe. And this really spells out the benefits. Taking that workload off the pilot's shoulders lets them manage the chaos of combat so much better. They can immediately focus on the most critical threat because they finally have the full picture. And maybe most importantly, getting that range data instantly shaves precious seconds off the decision-making timeline. Less time trying to figure out what a threat is means less time being in danger. It's a direct line. Faster data leads to safer pilots. But the story here is actually way bigger than just two jets. This new data link isn't just a solution for today, it's a foundational piece for a much larger vision of a totally connected future force.
Because the real game changer here isn't just that two jets can talk. It's that this is the first step toward building a secure, high-speed network where information flies seamlessly across the entire battlefield. It's about creating one perfect, common picture for absolutely everyone.
And the vision for this technology is huge. The next step is getting it onto other jets, like the F-16, so that different kinds of aircraft can all share this data. That then opens the door to really complex stuff like manned-unmanned teaming, where a pilot can coordinate a whole group of drones. And it's a critical piece for supporting joint all-domain operations. That's where the Air Force, Army, and Navy are all linked together. And the best part is, the whole system is built from the ground up to be upgraded, so it's ready for whatever comes next.
So in the end, this Datalink is doing so much more than just solving a technical problem. It's transforming what was once an individual sensor into a powerful collaborative network. And it leaves us with this one big question to think about. What becomes possible when every single pilot, no matter what they're flying, sees the exact same perfect picture of the battle? The answer to that is probably going to redefine air combat as we know it.